In this first video on partial fraction decomposition, we're going to be focusing on setting up the decomposition template. So there's a certain setup that partial fraction decomposition follows that really is not natural to your thinking. And so first you think it makes sense, and then we hit a little spot where it doesn't make sense. So you just watch as I go through these examples, and you will see how it goes. When you're given a rational expression, you want to rewrite it into simpler fractions. That's what partial fraction decomposition is. So if you were given a rational expression where the denominator was not already factored, you would have to do the work of factoring the denominator. In all of these examples we're looking at in this particular video, the denominators are already factored, so we don't have to worry about that. So we're going to use that to our advantage. As I go through these, I'm going to be doing the odd ones. What you need to do is attempt the even ones to turn that into me. So for number one, we have this 3x plus 2 over x plus 3 times x minus 2. We're going to rewrite this into separate fractions. The number of fractions is determined by what the denominator is. This will be written into as something over x plus 3 plus something over x minus 2. And we are going to figure out what belongs in the numerator in each of these. The general rule is whatever the degree of the denominator is, you want to make the numerator 1 degree less than that. The degree of this denominator, x plus 3, is 1. 1 minus 1 is 0, so the degree of the numerator needs to be degrees 0, which is just a constant term or a number. A is what I'm going to put up there for now until I figure out what belongs there. The x minus 2, I want to rewrite this as the numerator is going to be 1 degree less than the denominator. The denominator is degree 1, so 1 minus 1 is 0. We also just get a constant term right there. Once we figure out what a and b equal to, what their values are, we've rewritten this entire expression into its partial fraction decomposition form. In this particular video, all we're doing is setting up the template, and this is the template. So number 2 will be very similar to what I did in number 1. I'm going to leave that for you to do. Number 3, we see something different. Our denominator has a repeated factor. It's got x minus 1 times x minus 1. This is how you handle a repeated factor. You want to rewrite it into fractions, and the number of fractions will be determined by the number of repeated factors. So right here, x minus 1 is repeating 2 times. So I'm going to rewrite this into 2 fractions, x minus 1 to the first power plus x minus 1 to the second power. And then we must decide what goes in the numerator. What goes in the numerator is based on the power of what's being repeated. What's being repeated here is x minus 1. This is of degree 1. 1 less than that would be a constant term, a. What's being repeated here is x minus 1. So it would normally look like the highest power here is x squared. But since what's being repeated is just x minus 1, that's what we base our decision of the numerator on. So the degree is still 1 on x minus 1, so 1 less than that is still 1. We get another constant right there. Number 4 is very similar to number 3, so I'm going to look at some more examples. 5, we have 1, 2, 3 factors right here. This, I'm going to make this a minus sign. This looks like a equals. Here are this will be 3 separate fractions, something plus something plus something. The denominator is x minus 1, x plus 2, x minus 3. This is what our fraction setup will look like. 1 less than 1 is a constant. This is of degree 1. This will be a constant. This is of degree 1. This will be a constant. That's what that setup would be. Number 6 is very similar. Number 7, we have three factors. This is going to be something over x plus something over x minus 3 plus something over x plus 1. The degree of this denominator is 1. We get a constant. The degree of this denominator is also 1. We get a constant. The degree of this denominator is also 1, so the numerator will have a constant. 8 is very similar. Let's look at number 9. In the denominator, we have a factor of x minus 5. It's being repeated 3 times. That means that we have to make 3 separate fractions. The first denominator will have x minus 5 to the first power. The second one will have x minus 5 to the second power. The third one will have x minus 5 to the third power. Again, this is how you do partial fraction decomposition. It may not follow any logic that you've seen before. We base our decision on the numerator on what factor is being repeated. So again, what's being repeated here is just the x minus 5, which is of degree 1. So we get a constant in the numerator. Even though if we took x minus 5 times x minus 5, we would have x squared, something of degree 2. We base our decision for the numerator on the factor that's being repeated, which is x minus 5. So that's of degree 1. We get a constant up here. The factor that's being repeated is x minus 5, and so the constant c is what's going to go in that numerator. Number 10 is very similar. Let's look at the last few, number 11. Right here we have a repeated factor of x squared and then x plus 2. This means that we have to have one fraction with the x in the denominator, x to the first power, another fraction with an x to the second power in there, and then another fraction with this x plus 2 in the denominator. The degree of this denominator is 1. We get a constant. This looks like the degree is 2. However, this is a repeated factor of x is being repeated, so we just get a b right there. What goes in this numerator is degree 1, so we get a c right there, constant. Number 12 is very similar. 13 will look like this. If I look at this x squared plus 5x plus 7, it will not factor, so we're stuck with x squared plus 5x plus 7. So we're going to get one fraction with the x minus 3 in the denominator, and another fraction with this x squared plus 5x plus 7 in the denominator. What goes in this numerator will be 1 degree less than x minus 3, which has a degree of 1. So we get a constant right here. What goes in this numerator will be 1 degree less than what goes in this numerator, than what's in this denominator. This is of degree 2. So what goes in this numerator will be bx plus c. That's how you write 1 of degree 2. I'm going to go ahead and do 14 since we only saw one of these. This will be rewritten into this fraction, something over x plus 1, plus something over x squared plus 2x plus 5. The degree of this denominator is 1, meaning that the degree of the numerator needs to be 0 or a constant term. X squared plus 2x plus 5 won't factor, so we're stuck with this. The degree of this denominator is 2. That means we need to put in the numerator something of degree 1, which will be bx plus c. If, for instance, we had some fraction 3x squared plus 1 over x cubed plus 2x plus 5, we had something of degree 3 that would not factor. U times, let's say, x minus 1. We would rewrite this into something over x minus 1 plus something over x cubed plus 2x plus 5. Okay. 1 degree less than 1 is a constant. 1 degree less than 3 is degree 2. Here we would have bx squared plus cx plus d. I don't expect we'll see anything that big, but that's the pattern you would follow when you're doing partial fraction decomposition.